Hello. Now in this video, I will do an additional discussion about the last case that we have, or you can also call it a revision. And the revision is not big, but I think it will give us another insight regarding the case. Okay, so previously we have this data. We have 4 steps. The first 3 steps include flowing period and shut-in periods of 9 hours. And we have the last period, last step, which include 36 hours of flowing period and 24 hours for shut-in. And we plot all the 4 data, all right? And then we do the trend lining using those 4 data. And from that, you can see we arrange and we get the A parameter and B parameter. And from that, we calculate the absolute open flow or the maximum flow rate. And from the absolute open flow and static bottom hole pressure, we create the IPR, inflow performance relationship, right? That's our first approach. Now I will show you the second approach. And I think it's a little bit more preferable. And the approach is like this. So we can distinguish or we can differentiate the first 3 steps with the last step. Okay, the first 3 steps include flowing period of 9 hours and shut-in period of 9 hours. We can regard these steps as transient flow. Okay, so maybe I can add remark something like this. All right, and then I can call it flow regime. Okay, I will just assume, and I can regard the first step as transient flow, and then also transient because the flow period and the shut-in period are quite short. And the last one is pseudo steady state. Pseudo steady state. Okay. Okay. By assuming this, the best approach is you need to calculate the time to pseudo steady state flow regime. What is the time that is required to achieve or to reach pseudo steady state? That's the best, the most prudent approach. But let's say we can assume that the first 3 steps are transient flow, transient steps, and the last step is pseudo steady state step. All right. In that case, I will only use the 3 flow periods, the 3 steps to do the trend lining. Okay, so like this, I will do this one. So you see, the slope will be different. The slope will be changed. All right. If I control Z, the slope will be different. The equation will be different. If I redo, all right, the slope will be different, although the equation will not be that significant here. So the slope is 0.08832. So let's right click, format trend line, display equation. All right, you see, or maybe I can control Z first. So this is our original equation. All right, or our original equation. And now I want to do the trend lining using only the 3 data. Okay, the transient data. So I right click, format trend line, and yeah, now the slope is 0.0654. Okay, you got that? All right. And as such, we can copy and paste here as our backup value. And I will use this one, 0.0654. 654. All right. And then I will add select data. I will call it transient. And then I will add PSS, pseudo steady state. The X value is the flow rate, this one. And the Y value is this one. So this is my pseudo steady state flow period, pseudo steady state data, I mean. And then we create a parallel line like this, mimicking the slope. Say I want to make it quite long. So they have the same slope. And then I put this line on my pseudo steady state data. So here,